Hello, I'm Prabal Man Dhaubhadel. This is my presentation on cross-site scripting, commonly known as XSS. So what is cross-site scripting? It is a web security vulnerability that allows an attacker to compromise the interactions that users have with a vulnerable application. Now it also allows the attacker to circumvent the same origin policy, which is designed to segregate different websites from one another. Uh, Cross-site scripting is a client-side code injection attack. It is considered less severe than SQL injection, but in SQL injection, basically they're injecting SQL queries, but in cross-site scripting, they're injecting scripts, mostly JavaScript, but there can be other forms as well. Now, in cross-site scripting, basically the attacker will execute malicious scripts in the victim's web browser, and then the attack is executed when the victim visits that particular web page or web app. Now the tricky part here is that the browser has no way of knowing that the script should not be trusted. And in OWASP's top 10 vulnerabilities in 2020, cross-site scripting ranked 7. So let's look at some of the assets that can be targeted in a cross-site scripting attack. Since the adversary has control over the browser, he or she can access anything from cookies, session tokens, as well as sensitive information that can be retained inside the browser. Through XML HTTP requests, the adversary can make any number of anonymous requests, which can be very harmful, and depending on the privilege that is being retained, this can escalate even more severely. From HTML5, we can also gain access to geolocation data, webcam, as well as access the user's microphone. And also, cross-site scripting attacks can target the HTML of the page rather than the victim's information, where the HTML is defaced to produce a wrong version of the website depicting inaccurate information on the website. Now let us look at how cross-site scripting attacks work. Before we do that, let's understand the simple concept of payload. A payload is a malicious piece of code that is usually transmitted by the attacker to compromise a system. Now, in essence, the cross-site scripting attack is very simple. It is just 2 steps. In the first step, the attacker must find a way to inject the payload into a website. And in the second step, the victim must visit the website with the malicious code. To aid in step 2, usually attackers perform social engineering and phishing attacks to provide malicious URL to the victim. Like I also mentioned earlier, most of the cross-site scripting attacks are carried out through JavaScript, but they can also be carried out through Flash, HTML, ActiveX, and even CSS. Here's a simple example of a cross-site scripting attack. In the first step, the attacker injects a payload into the website's database by submitting a vulnerable form. Now, this form has malicious JavaScript. This way, the attacker has infiltrated the website's database. In here onwards, what happens is that whenever a victim requests a web page from the web server is going to serve the victim with the web page that contains the attacker's payload as part of the HTML body. Now what happens is, as the victim visits the web page, the malicious script that is contained in the HTML body gets executed, and in this case, it sends the victim's cookie information to the attacker's server. Now all the attacker has to do is basically extract the victim's cookie every time an HTML request arrives at the server. Now this way, the attacker can use the stolen cookie information to impersonate the victim. So let us now look at some of the code snippets that can be used to carry out cross-site scripting attacks. Since we discussed that JavaScript is the most popular way to inject these scripts, we're going to look at some examples of the similar nature. Now the first example is abusing the background attribute in the body tag. We can see that instead of providing a valid background image or a valid parameter, basically there is a JavaScript script being executed there, which is an alert. This is just an example, and in case of Instead of this alert, it could be something much more dangerous, like sending in tokens or cookie data or stuff like that. Now, in the second example is pretty similar to the first one, but it's a different abuse. We can see that the link tag is being abused, and likewise, the third example has an abuse on the input tag. Now, in the fourth example, we can see that instead of running a JavaScript element there, we can see that it is being redirected to some other page itself, and then that could be using something more malicious. And now that we have looked at some of the example code snippets, let's look at the different types of XSS. Basically, there are three different types. Those are reflected, stored, and DOM based. And they can be classified into server-side XSS and client-side XSS. Reflected and stored XSS are server-side XSS, whereas DOM-based XSS is a client-side XSS. So to give you more information, reflected XSS is where malicious script comes from the current HTTP request. It's also known as non-persistent XSS, and it arises when an application receives data in an HTTP request and includes that data within the immediate response in an unsafe manner. Now, the next type is stored XSS, which is where a malicious script comes from the website's database, like in the example that we saw above. This is also known as persistent XSS, and it arises when an application receives data from an untrusted source and includes that data within its later HTTP responses in an unsafe way. Now, the third type is the DOM-based XSS, which is where a vulnerability exists in the client-side code rather than the server-sided code. Now, this arises when the application contains some client-side JavaScript that processes the data from an untrusted source in an unsafe way, usually by writing the data back to the DOM. And now that we've understood what XSS is, to different examples and types of XSS, let's look at the impact of XSS attacks. Now, this will largely vary depending on the type of application and the amount of data being shared across that application. Now, the first type is brochureware applications where users are anonymous and there isn't really any data being shared publicly, and that all information of the website is public. So in this case, impact is minimal. Now, there are applications holding sensitive data such as credit card information, e-banking, email, healthcare records, where users share sensitive data. In this case, an XSS attack could be very serious, as information could be leaked and the attacker can gain access to very privileged information. Now, the third type of impact is where users have elevated privileges. Whenever an application which is being logged in by an admin privileged user is being compromised. In this case, attackers can take full control of the application, and then it can compromise the users as well as the data. And in these cases where root privileges or like elevated privileges is concerned, impact is very critical. Now that we know what XSS is, its different types, and then the impact that it can cause, let's look at some of the mitigation techniques. There are certain tools available on the internet that you can use to check if your website is prone to XSS attacks and how they can be mitigated, but there are certain general strategies that anybody can employ into their products. So the first one is training and awareness. This is a dev site mitigation where not only the developers, but also DevOps as well as QA and sysadmins are aware of the fact that their website could be vulnerable to XSS attacks, and they proceed with development likewise. The second one is distrust user input, where we treat input from authenticated and internal users the same way as we treat public input. The third type is using appropriate escaping and encoding technique depending on where user input is to be used. And the next type is sanitize HTML. In case of HTML, the escape and encoding mechanism does not work. So it is generally advised to use a trusted and verified library to parse and clean HTML, such as HTML Sanitizer. The next type is use of HTTP only flag for cookies. So if we do so, then cookies will not be accessible via client-side JavaScript. And the final type of mitigation that is generally suggested is CSP, which stands for Content Security Policy. CSP is an HTTP response header that lets you declare the dynamic resources that are allowed to load depending on the request source. Now let us look at a real cross-site scripting attack example. This comes from CVE 20191010307. This happened in the GLPI product version 9.3.1. So basically the impact is that all drop-down values are vulnerable to cross-site scripting, leading to privilege escalation and executing JS on admin. So now basically what it is saying is that the file getDropdownValue.php has a drop-down component which gets compromised, and then through the drop-down values, the cross-site scripting attack takes place. The attack vector is also shown, like how that attack is orchestrated. Basically, user creates a ticket, admin opens another ticket and click on the link tickets feature, and then this way, a request to the endpoint will fetch the JavaScript and executes it to compromise the system. So here's a simple fix that the developers have suggested, where they simply correct the content type in the auto-completion URLs. So we can see that there are total 7 changes which are identical, where they're only changing the content type from text HTML to application JSON. By doing this, what they're mitigating is that instead of allowing whole JavaScripts to be sent in as like an injected attack, it only accepts JSON. So that way what they're doing is that it's parsing that content, and whatever is undesired can be filtered out. With this, I've come to the end of my presentation. Here are the references.